Yes, hello everyone. I am Mohamed Al Yassi from Masdar Institute for Science and Technology. Today I will give my presentation about the developing a methodology and practical application of technical risk management for CubeSat projects. I will start to introduce my outline. I will start to introduce the risk and technical management. Then I will go to. Then I will move to give explanation about categorization methodology for technical risk management in CubeSat project. Then I will give a practical and real application that is applied in our CubeSat project, which is my Sat1. At the end, I will give advantage for applying this developed methodology that is applied for our CubeSat project. Starting with the define risk is defined as combination of likelihood of negative events and consequences. Resources can be causes from a scientist failure, such as thermal, power, mechanical, etc. Also, it can caused by limited engineering analysis, improper margin and reserves, improper implementation plans, and subsystem component failure. Moving to the technical risk management can be defined as collecting and controlling risks in projects in order to assign a proper mitigation plan. The applying the technical risk management is very important in order to increase project life cycles. Also, it can be used to increase the successful of mission, successful path toward acceptable risk level. It can also help to meet technical performance requirement and maintaining safety. This graph or this general graph or scheme can give a brief explanation about our methodology. Left side, as shown, it is quantitative risk management that is used to derive risk assessment plan. Right side is mitigation plan, which is derived from the qualitative risk management. This scheme is starting from basic classification, moving to the categorization into launch stages, till reach to the risk level classification, then move to choose handling approach section. After that, this handling approach section should be implemented in order to reduce the severity of the level risk. Quantitative risk management, first of all, can be classified into two main basic classification, which are implementation risk and mission risk. Implementation risk can be happen with pre-launch stage, and it has more probability for severity percentage to be reduced, while mission risk might be happen after launch and has less probability to be mitigate, while it is already the CubeSat will be in space, so it is deployed in space. All our risk scenarios can be categorized mainly under the stages of the project, which are pre-launch stage, during launch stage, after launch stage. This categorization helps us to define where the risk scenario can be start to be mitigated, or we can choose a certain approach to hold this risk scenario till it reached to the critical time to be mitigated. This table showing the level of the consequences that is used to be evaluated for each risk scenario, but this level is specified for two risk scenarios, which are, as I explained, implementation and mission risk. This table showing the lowest scale 1 to the highest scale 5, then move to the likelihood level. This table shows that level 1 is lowest and 5 is highest. This table can be used to evaluate risk scenario for both implementation risk and mission risk. By getting two results from consequences level and likelihood level, we can directly point where our risk scenario is from this 5x5 matrix risk assessment. After that, we will get the risk level. Then we can choose handling approach. This handling approach, it goes under the qualitative risk management. Now we will start qualitative risk management as mitigation plan. There are 6 types of the handling approach, starting with accept, mitigate, avoid, and research, work, and transfer. The first 3 are already integrated with this 5x5 matrix mitigation plan, which help us directly to choose which handling approach can be used. This matrix is just specified for the first 3 handling approach, which I already explained in this table: accept, mitigate, avoid. Moving to the practical application in CubeSat Project MySat, I would like to introduce our MySat project. It is the major aim for this project is to communicate between our ground station, which is already built in our space lab, with the CubeSat that will be deployed in space within a couple of the months. The aim for that is to download a minimum 1 picture weekly to discover the space and to take a picture of the space. Whatever the direction is. Our MySat it has structure. We build this structure depend on component, responsibility, and standard, as well as functionalities. It contains 6 subsystems, which are communication, electrical, computer, mechanical, payload, and ADCS. By starting with our technique, we observe that the highest risk scenario is located in payload subsystem, which indicate that our CubeSat it will be highly affected by the payload subsystem, while the payload subsystem is designed to achieve the major mission of our project by applying our technique for the risk scenario. After applying the quantitative method, we come up with the end result from a quantitative method, which is medium risk level, and by applying handling approach, we will reach to reduce the risk level to the low. Also here another example, and it is one example of the risk scenario during the launch. Also, it is the severity of the risk level reduced from medium to low. This is last example, which is the risk scenario is reduced from high severity of the risk level to the medium by applying our technique. At the end, we did some analysis to see the performance of our technique. It shows that within 3 stages of the CubeSat project, we can achieve 33.33% reduction of the severity risk level. The advantage of applying this technique, it is less time, less cost, simple, just using the table, and can be applied manually. Also, it reducing sufficient percentage of severity, about 33% for each risk scenario. At the end, it is the risk scenario can be observed in long and short term. Thank you for listening my presentation, and I appreciate your time for that.
Thank you very much, Hamid. Are there any questions? One question. We'll get a microphone to you. Hamid, you'll have to tell me if you can hear the question or not.
Yes.
Okay, 1 second.
Hello, can you hear us?
I'll just repeat it.
So, 2-part question. How do you assign the likelihood level of a one-off invented part? And second thing is, when you looked on you decided your payload had the most risk, how were you sure that you had a complete set of risk scenarios across all your different subsections, so that was a true statement the payload truly did have the most risk?
Again, I cannot clearly.
Okay.
No,
So the first part of the question was, how do you assign the risk to a one-off custom part?
How I assign a risk?
To a one-off custom part?
Yes, this seems the likelihood percentage. Where do you have data for that?
Where do you get the data?
Subjective.
Where do you get the data for the one-off part?
One of the risk?
Yes. How do you calculate that for a part that has never has been invented just for this specific mission? If there's no heritage or anything like that.
Because we first of all we have all the specification about this component, and also our requirement is specified. Then we start with creating one scenario that might happen by calculating the consequence and likelihood. We reach to the level of the risk, then applying a mitigation plan which is already tested in our space lab, using several type of instrument. And for example, if we found that our component cannot be pointed directly to the sun, and the lens might be damaged. So while changing the specification of the lens, and again we repeat the experiment, we saw that the percentage of the damage is reduced. I mean, in a practical way, not depend on like data mining or like collecting the information from the several CubeSat in previous time. Like.
Okay, that's great. Thank you very much. Okay, thank you. Any other questions? No? Okay, well, thank you very much, Hamid. And your talk will be online shortly.